All right, guys. Good morning. This is Miss Hammond. So, just a couple of things before you take your quick check. First, you're due now for today. I did not make it a Padlet because I wasn't online for us to have discussion. But the question, and it's similar to a question that you're going to see in your quick check, is what do all atoms of an element have the same? It's a poorly written question, but again, what do all atoms of an element have the same? So if I had carbon as my example, and I had 5 carbons, what potentially would all 5 of these carbons have the same? Would it be the number of neutrons, the atomic mass, the atomic number, or the mass number? So I'm going to pause and give you a moment to think about it. What would they all have the same? Think about some of the things that we've talked about. Remember the term isotope. What about isotopes of an element is different? Remember, I talked about if we use our example carbon, you have carbon 12, carbon 13, carbon 14. The difference in those carbons is that they have more neutrons than the original, which is carbon 12. So A would not be your correct answer. All elements of carbon would not have the same neutron number. That's for all atoms of any element because that element could potentially be an isotope. A is not the correct answer. The atomic mass of all elements is also not correct because of the same thing that we just mentioned about isotopes. If the neutron number can change, the atomic mass number can change because the atomic mass, remember, is an average of all of that particular element's mass numbers. It also potentially would not be D because the mass number is the number of protons added to the number of neutrons. And even though the proton number, just like the atomic number, never changes, the number of neutrons could change. Therefore, the mass number could also change. So the best answer to this question is the atomic number. Remember, your atomic number is located here. And remember, I stated yesterday when we were looking at the element box that the arrangement of the information could change. But for the most part, the atomic number is always a whole number. It's always, for the most part, at the top center or the top left. The element's name or the chemical name is always written out. The chemical symbol is a letter or, I'm sorry, it's a capital letter or a capital letter and a lowercase letter. Again, the correct answer to our do now is the atomic number. So the only thing we haven't had an opportunity to discuss is counting atoms. We know that whenever you look at chemical symbols on the periodic table, it's a representation of that one element, right? So, for example, carbon is C, aluminum is Al, fluorine is F. So the symbol for the element on the periodic table is made up of either 1 or 2 letters. The first letter is always a capitalized letter. So if you see 2 capital letters side by side, each capitalized letter represents a different element. There is a second letter present, similar to here in aluminum, it's always going to be lowercase. So compounds are made up of 2 or more elements that are chemically combined. This means that the elements were combined by some type of chemical change. Move on, take of time. All right. So when you're looking at a chemical formula, you're trying to figure out what elements are present and then how many of that particular element or atom are present. So here for number 1, do you believe that that's one element or more than one element? Hopefully you said an element. You have just the one capital letter, so that's a representation of one element. For number 2, you have a capital letter and a lowercase letter. That is still one element. Remember, we said if it's a capital letter and a lowercase letter, it's usually the symbol for one element. What about number 3? We have more than one capital letter. That one is a compound. The K and the CL represent two different elements. Let's look at number 4. We have a few letters here. The compound. The NA is one element, the O is one element, and the H is one element. All right, I'm gonna kind of go through these for time's sake. All right, so the symbol of an element represents one atom of that element, and we just discussed that. For example, we have a capital C and a capital O. If we're counting the number of atoms that are present, we have one carbon, we have one oxygen, but we have a total of 2 atoms. If there were a subscript, subscripts are numbers. They are usually going to be located after any one of these symbols to tell you how many of an atom is present. So a subscript in a chemical formula is a number written at the lower right corner after the symbol of an element. It represents the number of that atom of that specific element when there's more than one atom of that element. A little bar. So here we have Na2CO3. So that means we have 2 sodium atoms. We have carbon, but see, carbon doesn't have a subscript. So there's only one C. And we have oxygen, but there's a subscript after oxygen. So it's 2 sodium, 1 oxygen. So if there's no subscript written, it's understood that the number is 0, or you could say that it's 1. I would say that it's 1. So 1 carbon, and then we have 3 oxygens. And then they have it written out for you. What you should also do anytime you're trying to identify how many atoms are present, the first thing you should do is list the atoms that you see. So we would list sodium, we would list carbon, we would list oxygen, and then we would count how many atoms are present. So again, we said we had 2 sodium, 1 carbon, 3 oxygen. We added all those together, we would have a total of 6 atoms. So this is where we're going to end this presentation. All right, so counting atoms practice. So here we have, I'm not even going to try to say the name, but I think it's sodium um, carbon oxide, something like that. All right, so we know that we have, this is a capital letter and lowercase letter, so it is one symbol, one element, a capital letter, so that's one element, and one element. Sodium does not have a subscript, so it's understood that it's a 1. So you should have 1 here. Hydrogen, no subscript, so it should be 1. Carbon, no subscript, so it should be 1. Oxygen, no subscript, so it should be 1. Actually didn't. Oh, so let's fix it. All right, so we see we have 1, 1, 1. But you notice there is a subscript after oxygen. So oxygen would have 3. All right, so I know this video was kind of rushed and really short, but I wanted to make sure that you had enough time to do the quizzes. There are only 5 quizzes questions. The questions are only asking you about counting atoms because I feel comfortable that you know characteristics of metals and metalloids. Remember, metals have luster, they're shiny. Non-metals do not have luster, they are not shiny, they are not malleable, they are not ductile. So just think about those things. Long as you know characteristics of um, metals and nonmetals, you know metalloids have characteristics of both. I think you'll do very well. The periodic table that's present in the quick check is not a really good version. So I've attached a PDF or a website accessible periodic table that I would like you to use. If you want to download the one from the assignment from yesterday and use it instead of that, that's fine. But you will need access to a periodic table for today's quick check. All right, guys, I'm going to end my session. I hope you have a great weekend, and I'll see you next Wednesday.